In this exercise, we're going to set up a well. So let's open SES, get it up and running. Come out here to the well screen, click on Do Not Delete to create a new one, and then we'll hit Add. And we're going to add John Brown number 2, 1H. That's all. That's the only information that's absolutely required, is just strictly the name of the well. You can add a lot more information if you wish, like the field, the operator, who you are, our company, and so on. We can also define the surface location over here in this page as well. Default units, if we want to switch between feet and meters, we can do that here, and other information is other project information you want to include with it. Generally, this is something we never have to worry about. However, being international, we may well want to switch everything to meters, but for now, I'm going to leave it in feet. So once that's done, we hit close. It's already created, and I'll click on the SES screen. And here is our drop down to where we can pick any one of these wells that we have out in our database to actually work with. Obviously, the one we want to work with right now is the John Brown number 2. And the first thing we want to do is to create the offset well and define our tops. We said previously we have to have that offset gamma ray LAS file and the targets defined. So let's see what we have for this particular well. So here's our geoprog right here. It defines our target interval top as 5,200 feet. The target center line is 5,220, and the target interval base as 5,240. Okay, so we'll put that off to the side for a moment. And our LAS file is right here. So you can see what that's going to look like. This is our offset LAS file. It has a depth, a caliper, a deep induction, conductivity, density correction, and so on, finally down to actually deriving the gamma ray from the density log. That is the curve that we're going to use. So let's close that out. And come over to the type log screen, and I click on this little file button, and we're going to go out and find that LAS file and load it. So I'll scroll up here to the desktop, which is where it's located, and I will find this file, which is the offset file to our well. We click on over here, we can find our depth. That is always, always, always the first curve is the depth curve. The second one, we have to scroll down to find the gamma ray API. It has to be the API. So quite often you'll see gamma rays in other formats, but the one we have to use is the gamma ray API, and that's that one right there. We will hit import. It will now bring all of that gamma ray data into SES. The next thing it's going to ask is you have to define that target pay zone top. Again, let's refer back to our geoprog to be sure we get the depth right. The top of the target is 5,200 feet. So I'll come over here, I'll enter 5,200 feet right there in the pay zone top. I will hit enter, and notice now the gamma ray shifts to green, and the pay zone is now indicated over here in the log itself. So let's add a bit more information to our type log, since this is going to be a main source for us. It says the target center line is 5,220. So I will scroll down. Notice the RSDs here are changing as I scroll towards 0. And I went a little past it, and there's 0 right there. So I'm going to, in the zone information top, I'm going to put in target top right there, hit enter. I'm going to come down 20 feet to 5,220. which is right here. I'm going to put the center line right there, press enter. And the base, if I recall, is 5240, so we'll come on down to 5240 and type in target base right there. Now, at this point, we have defined the actual target zones, but I always like to have a bit more information for our customers, like where the bed tops are. So, let's come back to our GeoProg, and we can see some of the beds that are noted for us here. Tonkawa is probably too high, so let's start with the Cottage Grove at 4014. So I'll scroll up here to 4014. Right here. And I'll type in Cottage Grove. Okay. In a moment, you'll see the reasoning why I'm doing all of this. The second is the checkerboard limestone at 4530, so I'll come down to 4530. Checkerboard limestone is there. The Oswego limestone is at 4850. I'll put that one in there. And the Mississippian, which actually is our carbonate target for this well, is at 5140. 5140 is right here. Okay. Now, right now, we haven't done anything except define the pay zone over here. But if I click refresh, notice what happens. These various beds pop in and show up over here. Now, if I want to zoom in on some of this information, like the actual target zone, I come into our graphic, I left click, hold it down, draw it down with the mouse, and it will zoom to that part of the area, showing you a blown up view now of the Mississippian, as well as a target top, the center line, and target base. Now, one of the nice things about SES is that we can send this information to the cross section. We're not ready to create a cross section yet, but one of the things I like to do once I have got the type log defined is go ahead and send the information to that database that allows all the thicknesses and bed markers to be added to the cross section. So by clicking right there, I have sent them over there. So at this point, our type log data is now set up. The next thing we have to do is set up the surveys. So what I want to do now is go click on the surveys and let you see what these look like. These are the standard survey. This happens to be produced by Weatherford. A lot of this information you won't necessarily see, like this column over here for tool, whether it's gyro, MWD, or so on. The columns that we are interested in are survey, inclination, azimuth, the course length, the true vertical depth, the vertical section, the coordinates northing and southing, northing and easting are right here, and the dogleg severity. So we have to set up now our survey screen to where we can make the same calculations that the service company is doing. So I'll come over here to this screen. I'll move SES over a little bit so I can see what I'm doing, and come in here. Now we have to create a tie point. All the mathematics, the two and three-dimensional mathematics that allows this to work, is all based on a starting point. The tie point is that starting point. What I try and do is find where the actual kickoff is. And I look over here at the inclination, and you can see it's beginning probably right about here, 2082 measured depth. So I'm going to use 2082 as our tie point. So I'll come over here and I'll type in 2082 right there. Then I'll come in and type in 0.56 degrees. Then I'll come back and get the azimuth of 230.07. Put that in there. Clear up my mistakes. That's 282. I'll get it right here in a minute. All right, the next thing we want to do is now we have to tell the system what the true vertical depth is for this tie point. It's 2081.6. 2081.6. The northing is 1.21 degrees. And the easting is 14.96. Okay. Now, the next thing you have to really be careful of is this vertical section azimuth. That is the projected azimuth. Now, in this particular well, the vertical section azimuth is 0. So what we need to do is look up here and see if we can find any difference. You know, the proposed azimuth right there says 356.2 degrees. That's, for all intents and purposes, that's 0. So we're going to leave this vertical section azimuth 0. If it said 270 degrees, then we would want to enter 270 over here because we're drilling to the south. The next thing we need to do is now bring in the survey depth, inclination, and azimuth into the system. So I'll come down here below 2082 in the Excel spreadsheet, and then I will move my arrow key and then block it all the way down to the bottom of the well. Do a Control-C to copy it. I'll come over here, I'll click on the little star. I'll then left click to paste all of that information into it, all those 93 records. And then I'll tell SES to calculate it. It then calculates the surveys. It shows you what the well bore is at this particular point. Now, obviously, I have done a well that is completed. So, therefore, you see all the survey points all the way out to total depth. But it doesn't really matter, because if you only have 2 or 3 survey points past your tie-in depth, then that's where you will start. And then you will, for each individual survey after that, you will add the measured depth, the inclination, the azimuth, hit calculate, and then it will start filling in the well bore actually while you're drilling. Again, here is the vertical section, here's the northing and easting, and up here under 3D is the 3D version of the well bore. At this point, your well is now set up and you're ready to start geosteering once the gamma ray starts coming in.